Hey Quantum Explorers, welcome to Tech Curiosity Stream, where we turn brain-melting tech topics into something you can actually understand, without needing a PhD. Today, we're diving into the fascinating world of quantum computing. This is not just any ordinary tech talk. We're about to explore a realm where the rules of classical physics get turned on their head. So buckle up and get ready for a journey that will stretch your imagination and challenge your understanding of what's possible. If you're here to finally get what quantum computing is all about, and maybe impress your friends at parties, you're in the right spot. Quantum computing is one of the most exciting and complex fields in technology today. It promises to revolutionize everything from cryptography to drug discovery, and even artificial intelligence. But what exactly is it, and why is it such a big deal? Well, stick around, because we're about to break it all down for you. Before we dive into the quantum rabbit hole, do me a solid. If you're new here, subscribe and slam that notification bell like it's the button that launches a rocket. Trust me, you don't want to miss out on our future content. We've got a lineup of mind-blowing topics that will keep you at the edge of your seat. We've got years of mind-blowing content planned, and trust me, you don't want to miss a single video. Now, let's get back to quantum computing. Imagine a world where computers can solve problems that would take today's fastest supercomputers millions of years to crack. Sounds like science fiction, right? Well, with quantum computing, this could soon become a reality. But to understand how, we need to take a closer look at the quantum world. Quantum computers operate on principles that are fundamentally different from classical computers. While classical computers use bits as the smallest unit of data, quantum computers use quantum bits, or qubits. These qubits can exist in multiple states at once, thanks to a property called superposition. This allows quantum computers to process a vast amount of information simultaneously. Buckle up, grab some snacks, and let's bend reality together. Quantum computing is not just about speed, it's about solving problems that are currently unsolvable. For example, in the field of cryptography, quantum computers could break encryption codes that are considered unbreakable by classical computers. This has huge implications for data security and privacy. But that's just the tip of the iceberg. Quantum computing could also revolutionize fields like medicine by simulating complex molecular structures to discover new drugs. Imagine a computer, not just any computer, but one that operates on the principles of quantum mechanics. This is a computer that doesn't just process information in a linear fashion, but explores multiple possibilities simultaneously. It's like having a supercharged brain that can think of countless solutions at once. This is the promise of quantum computing, and it's what makes it so revolutionary. It's not like the one you use every day. This computer is different. It's not just faster, it's fundamentally different in how it processes information. While your everyday computer uses binary code, ones and zeros, to perform calculations, a quantum computer uses qubits that can be both 1 and 0 at the same time. This is due to a phenomenon known as superposition, which allows quantum computers to perform many calculations simultaneously. It uses the laws of the quantum world. The quantum world is governed by principles that are very different from the classical world we're used to. In the quantum world, particles can be in multiple places at once, and they can be entangled, meaning the state of one particle can instantly affect the state of another, no matter how far apart they are. These principles are what make quantum computing so powerful and so different from classical computing. The quantum world is very small. It's the world of atoms and the tiny particles inside them. To understand quantum computing, we need to understand the behavior of these tiny particles. In the quantum world, particles don't behave in predictable ways like they do in the classical world. Instead, they exist in a state of probability, where they can be in multiple states at once. This is what allows quantum computers to process information in ways that classical computers can't. It's the world of atoms and the tiny particles inside them. These particles follow the strange and fascinating rules of quantum mechanics. For example, a particle can be in a state of superposition, where it exists in multiple states at once. It can also be entangled with another particle, meaning the state of one particle can instantly affect the state of another, no matter how far apart they are. These properties are what make quantum computing so powerful. This new type of computer is called a quantum computer. Quantum computers are still in their early stages of development, but they hold the promise of revolutionizing many fields. They have the potential to solve problems that are currently unsolvable by classical computers. For example, they could simulate complex molecular structures to discover new drugs, optimize supply chains, and even solve complex mathematical problems that are currently beyond our reach. You might be wondering, why do we need a new kind of computer? Our current computers are already very powerful. They can perform billions of calculations per second and solve many complex problems. But there are some problems that are too hard for even the best computers we have today. These problems are like incredibly complex puzzles with so many pieces and possibilities that it would take our current computers millions of years to solve them. Our current computers are already very powerful. They can perform billions of calculations per second and solve many complex problems. But there are some problems that are too hard for even the best computers we have today. These problems are like incredibly complex puzzles with so many pieces and possibilities that it would take our current computers millions of years to solve them. This is where quantum computers come in. That's true, but there are some problems that are too hard for even the best computers we have today. These problems are like incredibly complex puzzles. They have so many pieces and possibilities that it would take our current computers millions of years to solve them. This is where quantum computers come in. They have the potential to solve these problems much faster. These problems are like incredibly complex puzzles. They have so many pieces and possibilities that it would take our current computers millions of years to solve them. This is where quantum computers come in. They have the potential to solve these problems much faster. Quantum computers use the principles of quantum mechanics to process information in ways that classical computers can't. This allows them to solve problems that are currently unsolvable. They have so many pieces and possibilities that it would take our current computers millions of years to solve them. That's where quantum computers come in. They have the potential to solve these problems much faster. Quantum computers use the principles of quantum mechanics to process information in ways that classical computers can't. This allows them to solve problems that are currently unsolvable. That's where quantum computers come in. They have the potential to solve these problems much faster. Quantum computers use the principles of quantum mechanics to process information in ways that classical computers can't. This allows them to solve problems that are currently unsolvable. For example, they could simulate complex molecular structures to discover new drugs, optimize supply chains, and even solve complex mathematical problems that are currently beyond our reach. They have the potential to solve these problems much faster. Quantum computers are still in their early stages of development, but they hold the promise of revolutionizing many fields. This includes medicine, materials science, and artificial intelligence. For example, they could simulate complex molecular structures to discover new drugs, optimize supply chains, and even solve complex mathematical problems that are currently beyond our reach. Quantum computers are still in their early stages of development, but they hold the promise of revolutionizing many fields. This includes medicine, materials, science, and artificial intelligence. For example, they could simulate complex molecular structures to discover new drugs, optimize supply chains, and even solve complex mathematical problems that are currently beyond our reach. The possibilities are endless and the potential impact is enormous, but they hold the promise of revolutionizing many fields. This includes medicine, materials, science, and artificial intelligence. For example, they could simulate complex molecular structures to discover new drugs, optimize supply chains, and even solve complex mathematical problems that are currently beyond our reach. The possibilities are endless, and the potential impact is enormous. So let's dive in and explore this exciting new world of quantum computing. The journey ahead is filled with incredible discoveries and groundbreaking innovations. Stay tuned as we unravel the mysteries of quantum mechanics and uncover the true potential of quantum computing. Together we'll explore how this revolutionary technology can change the world and shape the future. So grab your virtual lab coat and let's get started on this quantum adventure. Quantum computers can solve problems that traditional computers find impossible. These machines leverage the principles of quantum mechanics to process information in fundamentally different ways. Unlike classical computers that use bits as the smallest unit of data, quantum computers use quantum bits or qubits. This is because they work differently. While a classical bit can be either a 0 or a 1, a qubit can be both at the same time thanks to a property called superposition. This allows quantum computers to perform many calculations simultaneously. Imagine you want to find a specific grain of sand on a beach. The sheer number of grains makes this task incredibly daunting. A traditional computer would have to look at each grain of sand one by one. This sequential approach is time-consuming and inefficient for complex problems. This would take a very long time. The limitations of classical computing become evident when dealing with large data sets or intricate calculations. A quantum computer could look at all the grains of sand at the same time. This parallel processing capability is what makes quantum computing so powerful. It would be like having millions of eyes looking for that one grain. This ability to process vast amounts of data simultaneously opens up new possibilities in various fields. This is just one example of how quantum computers can change the world. They have the potential to revolutionize industries by solving problems that are currently unsolvable. Quantum computers will help us design new drugs and materials. By simulating molecular interactions at an unprecedented level of detail, they can accelerate the discovery of new treatments and materials. They will accelerate artificial intelligence. Quantum algorithms can enhance machine learning models, making AI systems more efficient and capable of solving more complex problems. They will even help us understand the universe better. Quantum computers can process astronomical data at a scale and speed that classical computers cannot match, leading to new insights into the cosmos. The potential applications of quantum computing are vast. From cryptography to climate modeling, the impact of quantum technology will be far-reaching. They are only limited by our imagination. As we continue to explore and develop this technology, the possibilities for innovation and discovery are endless. Traditional computers use bits. A bit is like a light switch. It can be either on or off, representing 0 or 1. Quantum computers use qubits. Qubits are like a dimmer switch. They can be 0, 1, or both at the same time. This both at the same time state is called superposition. It is one of the key principles of quantum mechanics. Superposition allows qubits to store and process much more information than bits. Think of it like this. A bit is like a coin that can only be heads or tails. A qubit is like a spinning coin that is both heads and tails at the same time until we stop it. This unique property of qubits gives quantum computers their incredible power. Section 4, Quantum Mechanics, Superposition and Entanglement. We've talked about superposition, but there's another bizarre quantum phenomenon that powers quantum computers' entanglement. Entanglement is like an invisible link between two qubits. Imagine two spinning coins. They are linked so that if one lands on heads, the other one instantly lands on tails, no matter how far apart they are. This is what happens with entangled qubits. They are connected in a way that lets them influence each other instantaneously, even across vast distances. This spooky action at a distance is what Einstein called spooky action at a distance. Superposition and entanglement are the two pillars of quantum computing. They allow quantum computers to perform computations in ways that are impossible for traditional computers. Section 5, Quantum Supremacy. You might be wondering, if quantum computers are so powerful, why don't we have them already? The truth is, building and controlling quantum computers is incredibly difficult. It's like trying to build a computer chip out of individual atoms. Scientists are working hard to overcome these challenges. They have already achieved a significant milestone: quantum supremacy. Quantum supremacy is the point where a quantum computer can perform a task that is impossible for any classical computer to do in a reasonable amount of time. In 2019, Google claimed to have achieved quantum supremacy with their Sycamore processor. This was a major breakthrough. However, we are still many years away from having practical, fault-tolerant quantum computers that can solve real-world problems. Section 6. The future of quantum computing. The future of quantum computing is full of possibilities. As we stand on the brink of a new technological era, the potential applications of quantum computing are both exciting and transformative. Imagine a world where computational problems that currently take years to solve could be completed in mere seconds. This is the promise of quantum computing. Quantum computers have the potential to revolutionize many fields. From cryptography to complex simulations, the capabilities of quantum computers extend far beyond what classical computers can achieve. For instance, in the realm of cryptography, quantum computers could break codes that are currently considered unbreakable, leading to a new era of secure communication. They could lead to new discoveries in medicine, materials science, and artificial intelligence. In medicine, quantum computing could enable the simulation of complex biological processes, leading to breakthroughs in drug discovery and personalized medicine. Imagine being able to simulate the interaction of a drug with a human body at the molecular level, predicting its effects with unprecedented accuracy. Imagine a world where we can design personalized medicine based on our DNA. This means treatments tailored specifically to an individual's genetic makeup, increasing their effectiveness and reducing side effects. The implications for healthcare are profound, potentially leading to cures for diseases that are currently untreatable, or create new materials with unimaginable properties. Quantum computing could revolutionize material science by enabling the discovery of new materials with unique characteristics, such as superconductors that work at room temperature or materials that are incredibly strong yet lightweight. These advancements could transform industries ranging from construction to electronics. Quantum computers could make these dreams a reality. The ability to solve complex problems that are currently intractable opens up a world of possibilities. From optimizing supply chains to developing new algorithms for artificial intelligence, the impact of quantum computing will be felt across multiple sectors. However, there are also ethical considerations. As with any powerful technology, the potential for misuse exists. Quantum computing could be used to invade privacy, disrupt financial systems, or even create new forms of cyber warfare. It is essential to address these ethical concerns as we develop and deploy this technology. Like any powerful technology, quantum computing can be used for good or evil. The dual-use nature of quantum computing means that it can be a tool for both innovation and destruction. Ensuring that it is used responsibly will require collaboration between governments, industry, and academia. It's crucial to establish ethical guidelines and regulations for its development and use. Policymakers must work together to create a framework that promotes innovation while safeguarding against potential abuses. This includes setting standards for data privacy, security, and the ethical use of quantum technologies. One thing is certain: quantum computing is a game changer. The breakthroughs we achieve in this field will have far-reaching implications, transforming industries and improving lives. The excitement among scientists and researchers is palpable as they push the boundaries of what is possible. It's a journey into the unknown, full of challenges and opportunities. The path to realizing the full potential of quantum computing is fraught with technical hurdles, but the rewards are immense. As we continue to explore this new frontier, we will encounter both expected and unexpected challenges that will test our ingenuity and resilience. As we delve deeper into the quantum realm, we can expect to see amazing breakthroughs that will shape the future of humanity. The transformative power of quantum computing will touch every aspect of our lives, from healthcare and finance to energy and transportation. The future is quantum, and it is closer than we think. And that's your crash course in quantum computing. We've covered qubits, spooky algorithms, and why the future might need a lot more freezers. The journey into the quantum world is just beginning, and there is so much more to learn and discover. Stay tuned as we continue to explore the fascinating world of quantum technology. If your brain hasn't exploded yet, hit like, share this with your curious squad, and subscribe if you haven't already. Oh, and ring that notification bell. We've got deep dives on AI, black holes, and more coming soon. Your support helps us bring you more exciting content, so don't forget to engage with us on social media. Thanks for geeking out with us. Remember, the quantum future isn't just for scientists in lab coats. It's for you, the dreamers, the tinkerers, the ones who ask, what if? Whether you're a student, a professional, or just someone with a passion for technology, you have a role to play in shaping the future of quantum computing. See you in the next video. Until then, stay curious. Keep asking questions, keep exploring, and keep pushing the boundaries of what is possible. The future is bright, and it's filled with endless possibilities.